Hey everyone, today we are looking at LeetCode question number 20, which is valid parentheses. In this question, we are giving a string S which contains these characters, three types of opening brackets and the corresponding closing ones, and we need to determine if the input string is valid or not. We have three conditions to check if the string is valid. First, open brackets must be closed by same type of brackets. A square bracket can be closed by a square bracket only, and a square bracket cannot be closed by a curly one. Number 2, open brackets must be closed in the correct order. So if a square bracket is followed by a curly bracket, the curly one needs to be closed first and then the square. Something like this would be invalid. Third, every closed bracket has a corresponding opening bracket. Strings should have equal number of opening and closing brackets. Having more opening or more closing brackets would make the string invalid. So let's analyze and check if the strings are valid or not. Now let us take an example of a valid string. Suppose we have something like this. Now this is a valid string. We'll notice the order in which our opening brackets exist is same as the order our closing brackets will exist. For this example, first there is a parenthesis, then a curly bracket, and then a square. Now the closing ones would be in the same order unless there is some other opening bracket. So the key rule to follow is that the last to open would be the first to close. This rule is followed in every valid parenthesis. Now whenever such a case arises that the last matching thing needs to come first in the case, the data structure used is always stacks. Stacks follow last in first out principle. Basically they store data in a reverse order, so whatever is on top would be added at the last. Suppose for this string, where each bracket is an individual character, we create a stack of characters. We start from the first bracket. It's an opening bracket, so we'll push it onto a stack. Then the next, again an opening curly bracket, we'll push it onto a stack. The third, opening closed bracket, we'll push it onto the stack. Now we come to our first closed bracket. If it's a closing bracket, we need to check if this condition is matched or not. So we check the top of the stack. The top should be the matching opening bracket, because the most recent opening bracket must be closed first. If it matches, we pop it from the stack. And we continue our iteration. Again we come up to a closing bracket, we match it from the top of the stack. If it makes a pair, we pop it and we continue. We reach an opening bracket and we push it onto top of the stack. A closing bracket, we check the top, it matches, thus we pop it out again. We come to the last closing bracket, its corresponding opening bracket is present in the stack and we pop it out. Thus, by the end of the iteration, the stack should be empty and all the closing brackets would have matched from the opening ones. In such a case, the string would be termed as valid. So this is the rule. If it's an opening bracket, push it onto the top of stack. If it's a closing one, match it with the top. If such a situation arises when the stack is empty or a valid match is not available, then the string is termed invalid. Looking at some corner cases, first, when the opening and closing brackets don't match. So when we come at this closing one and we check that it doesn't match with the opening, we return a false. Second would be when the number of closing brackets is more than the number of opening brackets. So when we come to check this closing bracket, we would find the stack to be empty and thus we would be returning false. Third closing case, when opening brackets are more than the closing brackets. For example, something like this. So once we are done with the iteration, we check if the stack is empty or not. If it is empty, then it's a valid string. If not, if we still have characters present in it, then we'll return false and thus the string is invalid. So to summarize, we need to push all opening brackets onto the stack. For closing brackets, we need to check the top and pop if matched. If unmatched or stack is empty, then it's an invalid string, and at the end, the stack must be empty for the string to be valid. And that's the valid parenthesis problem. It's a simple idea once you recognize the last open, first close pattern, but handling edge cases carefully is the key. Let us code it once. So let's code this once. We have a string s. We start by creating a stack of character. We'll run a loop from I is 0 till the length of the string s. And we take the character at the ith position. If the character is of type opening bracket, so if it is this, or C is of type this, or C is of type opening square, we push it to the top of a stack. Else, if it is a closing bracket, we need to check first that the stack should not be empty. We take the top of the stack we then check a character. The closing should be we take the top character of a stack, store it in top. Then we go on checking if the type of the closed matches the type of the open. So if C is of type this and top is not, we then return a false. If C is of type curly O, oh, we just made a mistake. This should be the closed and top should be the opening one. Similarly, if C is a closed curl and top is not equal to an opening curly bracket, we return a false. If C is equal to a closed square bracket and top is not equal to an opening square bracket, we again return a false. Now this was the case if stack is not empty. If the stack turned out to be empty, we would also return a false. This would be cases where the number of closing is more than the number of opening. And then at the end of a for loop, we would be checking if the stack is empty or not. So we simply return stack is empty. Yeah. Let's run our code once.
And there you go. Thank you so much for watching this video.